Hey everyone, welcome back to the channel. If you're new here, today we're diving into some seriously next level robotics. Before starting the video, don't forget to subscribe to the channel and open the bell. Imagine a robot that not only sees and hears you but understands you, reasons with you, and acts on your commands in real time. A robot that picks up an unknown object you've never shown it before and hands it to you cleanly, precisely, and reliably. Welcome to the future. Welcome to Helix. In a world where robots have traditionally been rigid, pre-programmed, and unable to generalize, Helix dares to break the mold. Today, you'll see how this groundbreaking humanoid system is transforming the boundary between language, vision, and action, merging them into a seamless intelligence that can operate in the real world. Stay tuned, because by the end of this video, you'll not only understand why Helix is a leap forward, but you may also start to imagine your life with one by your side. In this video, we'll explain what Helix is, what makes it different from conventional robots, show you how it works from vision to language to motor control, highlight the key breakthroughs that enable it to generalize to new objects and scenarios, and finally, discuss what it could and might not yet do in a home or real-world environment. Whether you're a robotics enthusiast, an AI researcher, or just someone curious about the future, this one's for you. To understand why Helix is such a big deal, we need to step back and ask, what's wrong with most robots today? Conventional robots are either specialized arms in factories, or narrow task machines trained on very specific data sets. They struggle when faced with new objects, cluttered environments, or instructions phrased in natural language. You often have to program or retrain them for each new scenario. That lack of flexibility is what keeps many robots confined to labs or factories. Helix, by contrast, is built to generalize, to take in what it sees and what you say and to act accordingly, even if it's never seen exactly that object or setting before. It's a unified vision language action VLA model that combines perception, semantics, and motion control into one coherent system. The result? Robots that don't just follow scripts, they respond. In fact, in demonstrations, Helix has manipulated thousands of new household items it never trained on before, simply through natural language prompts. That kind of flexibility could ultimately move robots from industrial cages into our homes. Let's break down how Helix actually works. It's fundamentally divided into the complementary systems. System 2 or S2 is the high-level, slower interpreter. It uses a vision language model to combine camera inputs with natural language commands. Running at about 7 to 9 Hz, its job is to understand the scene, interpret context, and output a semantic goal representation. System 1 or S1 is the fast, low-level motor controller. It takes the semantic goal from S2 and translates it into continuous, high-frequency control signals for the robot at 200 Hz. That means controlling wrists, fingers, torso, and head in real time. The beauty lies in the separation. S2 figures out what to do. S1 figures out how to do it moment by moment. Because both systems are trained end-to-end together, Helix can smoothly pass information between planning and execution without disjoint modules or manual tuning. It uses one set of neural network weights for all behaviors, whether it's grasping, stacking, or handing objects to another robot. During training, about 500 hours of teleoperated robot data were collected. The robot motions were paired with hindsight language instructions. Essentially, the system learned what command would have led to that motion, and then it was trained end-to-end to map images and language directly to motion outputs. Now let's talk about what Helix can actually do. First, full body coordination. Helix controls 35 degrees of freedom, including fingers, wrists, elbows, torso, and head, all working together in smooth harmony. When the robot reaches for an object, its head tracks its hand, the torso adjusts for reach, and the fingers precisely grasp the target. That kind of coordination is extremely complex, but looks almost human. Second, zero-shot object manipulation. Helix can handle items it never saw during training: glassware, toys, tools, clothes, and irregular shapes. You can say things like pick up the red object on the left or give me the cactus-looking item, and it figures it out without pre-programming. Third, multi-robot collaboration. In one demo, two Helix-powered robots worked together to store groceries. They passed items back and forth, coordinated actions, and even used natural language like hand me the cookies or put this in the drawer, all without hard-coded task logic. Fourth, emergent behaviors. Because Helix isn't scripted, it develops subtle self-awareness. It can estimate its own task completion percentage, making multi-step actions smoother and more natural. Finally, everything runs on embedded GPS inside the robot. That means no massive cloud servers, no internet dependency, just real-time intelligence running on board. Of course, there are limitations. Environments outside controlled labs still pose problems with lighting, occlusion, and reflection. Heavy or irregular objects can exceed its grasp strength. Tasks that require fine tool use or detailed assembly are still too complex. Long-term reliability also needs more validation, and safety checks like collision handling must be refined before Helix can safely operate around people for extended periods. So while Helix is a leap forward, it's not a household robot just yet. Still, the progress is undeniable. Helix isn't just another humanoid robot, it's a milestone in generalization. It doesn't memorize. It understands. It doesn't execute instructions blindly. It interprets intent. This is the kind of technology that redefines what it means for machines to learn. So that's your deep dive into Helix, the humanoid that blends vision, language, and action like never before. It's a paradigm shift in robotics. Instead of scripting every scenario, you simply say what you want, and it figures out how. If you enjoyed this breakdown and want to see full demo videos, technical analysis, and future updates as Helix evolves, don't forget to like, subscribe, and ring that bell. And tell me in the comments, what would you ask Helix to do if you had one in your home? Thanks for watching, and I'll see you in the next video where we test Helix's limits and maybe, just maybe, go beyond them.